Okay, so we're starting at 2.12, the application of tangent ratios. So what did I say? If you see the word application, what's that mean or refer to for us? Remember from the other day we talked about this? No, no one remembers. It just means that these are probably going to be real life scenarios. Okay, or they're going to be the long answer question. So if you ever see application, you're probably going to have to follow those steps. So remember our let X be statements. We got to show our work, and then we got to do what at the end once we're finished. Yeah, therefore, and write something. Yeah, we got to write our concluding statement, right? So whenever we see an application question, if you see on your test it says application, make sure you follow those steps, okay? That's what we're looking for during that time. And we're using tangent ratios. So tangent ratio, what is it again? Tan x is equal to? I'm hammering this into your heads so that you never forget, because you will use it this year and you will use it again next year. Okay, so the easier you know it, the better it is. So once again, instructions are to show all your work to guarantee full marks. Introduce the unknown measurement with a let X be statement. Write a concluding statement. Round off your tangent answers. So that's when we have tan and it ends up being like 0.5, 0, 6, 7, 8, 3, 2, 4, whatever. We got to round that to 4. And then our length answers, we round to 1 decimal. And our degrees, we always try to get to our nearest degree, okay? So if it's 30.15, what's the nearest degree? 30.15. 30, right? So if it's 30.15, closest one, if we rounded it to, would just be 30 degrees, right? Okay, so here's our example. I think it's really blurry on your guys' handout, if I'm not mistaken. Yeah, it is super. Oh, okay. Well, there we go. Got good eyes. So here in my cool color copy it says a tree is located 6 meters from the base of the wall from the main entrance of the school. Okay, so I'm just going to draw that line. If you guys want, there's some rulers in there. If you want, if not, do what you need to do. But on a test, I expect a ruler. Okay, tests are quick. So this measure right here is 6 meters from the base of the wall near the main entrance of a school. A line from the base of the tree to the roof makes a 63-degree angle with the ground. What is the height of the wall? So what they're looking at here is that from the base of the tree, see if I can do this, boom, to the height of the wall or the top of the building, there it makes a 63-degree angle. So make sure you draw this on your, either draw it below or right on your example there. And if we think about it, of course, I ruined my nice lines there. If we think about it, we basically have a triangle, okay? We now have a triangle. And our job is to find out the height of the school. So if I made this triangle A, B, C, what side are we trying to find? A to C, right? So we're trying to find that side. Now, whatever it says in the last sentence of one of these application questions typically is what we're trying to find or what the unknown is. So the unknown here is the height of the wall. So what will our let X be statement look like? Exactly. Short and sweet. Let X be the height of the wall. So that would be your statement. Okay. Always have that statement. And if we wanted to kind of check it off our list, boom, introduced the unknown measure with a let x be. And then in this case, I could just put an x right there, right? Or on the outside of it. And that just shows us that's what we're trying to find. Okay. Now, if we have this triangle, what's our angle in question? Or what's the angle we know? 63, or angle B. What side is our opposite? A to C, so our opposite's over here, and our adjacent's where? Adjacent's down here, right? And then what's this side called? Hypotenuse. But we don't need that for tan, right? And truthfully, we are not given that, so we can't use it. You'll also notice moving forward that you got to play around with what you have. So you're going to find out that we use tan if we have an angle and one of the measures. And once we know what we're trying to find, so in this case, we're trying to find the opposite. Well, we know that opposite and adjacent, that's TOA, that's tan. So we're going to use tan to do it. Now, if I write out my tan x is equal to opposite over adjacent, we can begin to fill in our unknowns, or we can begin to fill in our knowns as well. So in this case, what would our equation look like? Yeah, go. Okay, go for it. Yeah. Tan 63 is equal to x over 6. Is that what we had? Sweet. Okay. What's our next step? Yep. Yeah, find what 63 tan is. Exactly, or tan 63. Which is what? 1.9626, I completely agree, is equal to x over 6. So as always, we're trying to find our unknown, and our unknown being x. So what would be next? Yep, you got it. We're cruising now, cross multiplication. So since it's division on that side, to bring in a cross equal sign, we make a multiplication. So it'd be 1.9626 times 6.0 equals x. And our answer to rounded to one decimal place, yeah. It's a side length, so to one decimal place. So I got the answer of 11.7756. So what would it be to one decimal place? 11.8, right? So 11.8 would be our answer. If they were asking for an angle, absolutely that would be correct. But they're asking for a side length, okay? So what's the last thing we need to do here? What would our sentence be, my friend? You got this. The what? Except I was wrong about the centimeters. That's on me. It's meters. That'd be the shortest wall ever. We're good? Questions, concerns, comments? Nothing? All right.